There are lots of important things in modern physics that are usually left out of the literature. These are the unmentionables. In the case of Hubble cosmology, one of the things that nobody will tell you is the fact that it's not actually compatible with Einstein's system. My name is Eric Baird, and you are watching True Physics. As everybody knows by now, our universe is generally reckoned to be a spatial hypersphere and expanding in size, and lazy writers often give Albert Einstein the credit for both ideas. However, both suggestions predate Einstein by an awfully long time. Regarding hyperspherical universes, Blaise Pascal's writing, published posthumously in 1670, famously said, "Nature is an infinite sphere, the centre of which is everywhere, the circumference nowhere." In the 1820s, the subject of the non-Euclidean geometry of curved surfaces and spaces was invented almost simultaneously by János Bolyai in Hungary, Nikolai Lobachevsky in Russia, and Carl Friedrich Gauss in Germany. In 1838, Edgar Allan Poe's last major work, Eureka, declared that we thus establish the universe on a purely geometrical basis. It then gave the Pascal quote, adopted a geometrically hyperspherical space, and added expansion and eventual recontraction. Bernhard Riemann then developed the mathematics of multidimensional curved spaces in the 1850s, and William Kingdon Clifford translated and popularized Riemann's work before dying of exhaustion in March 1879. All this work was done before Einstein was even born.
Before we look at Hubble cosmology, we need to know something about Newtonian gravity.
To calculate the gravitational redshift or blueshift on a signal, all we need is the velocity change associated with the gravitational drop and a Doppler equation. These sequential operations don't cancel perfectly, leaving a residual redshift. Let's trace a signal's round-trip path through a gravity well using Newtonian mechanics. As the signal descends into the well and climbs back out, undergoing two frame transitions, the frequency shifts do not perfectly cancel out as one might intuitively expect. So according to the Newtonian equations, a signal sent across a gravity well returns to its initial height with a net Lorentz squared redshift after two frame transitions. When light signals travel across vast cosmological distances, they pass through countless gravitational fields. These cumulative gravitational encounters naturally produce a distance-dependent redshift. The further the signal travels, the greater the redshift.
This gives us the Newtonian version of Hubble redshift.
These cumulative distance effects can also be interpreted as the side effects of spatial expansion.
If we choose to interpret these redshifts as recession velocities, with everything moving away from everything else, then the universe is an expanding hypersphere. On the other hand, if we choose to interpret the redshift as gravitational, the universe must have been denser in the past, and, once again, uniformity plus continually reducing density gives an expanding hypersphere. The result of the time asymmetry that's inherent in Newtonian physics is a Hubble-like redshift and an expanding spherical universe. Similarly, non-Euclidean geometry tells us that if we scatter sources of positive curvature around a region, such as stars, then the region becomes positively curved overall, and this curvature is cumulative. For any given uniform density of stars, the total amount of curvature increases as we look at larger and larger expanses of space until we get to a special scale at which the entire universe is wrapped around on itself as the higher dimensional version of a sphere. This means that our long-distance signal still ends up being redshifted as a function of distance, even if it somehow manages to avoid intersecting any gravity wells. The cumulative gravitational redshifts in the Newton-based model and the cumulative curvature in geometrical gravity seem to be describing the same thing. None of this works in Einstein's system.
In Einstein's 1916 system, physics must operate exactly the same way in backward and forward time. Because of this time symmetry, his gravitational shift equations are perfectly symmetrical. If a light signal travels out of a gravity well and then returns, the outbound redshift and inbound blueshift cancel perfectly. Over a round trip, energy is neither lost nor gained. Einstein's original system predicts no distance-dependent residual redshift.
To quickly double-check that we're correct, let's look at the Einstein gravity shift predictions in Robert Wald's textbook General Relativity. Once again, if we swap the start and end heights R1 and R2, the equation inverts. If a signal undergoes two successive shifts, one red and one blue, with the same height interval, the two shifts exactly cancel each other out. With Einstein's system, there is no net gravitational redshift, no distance-dependent redshift, and no distance-dependent curvature.
When Einstein switched to a spherical universe in 1917, he needed to cancel out the cumulative positive curvatures. This was done with a completely new effect, which Einstein called the cosmological constant, represented by the Greek capital letter lambda. Lambda acted as a negative anti-gravitational curvature, deliberately included to force his universe into a quasi-Euclidean state. When Edwin Hubble published his 1929 results, he showed that distance-dependent redshifts were indeed real. This observation validated the idea of an expanding universe, something Einstein had actively opposed.
When Georges Lemaitre had suggested to Einstein that the universe might be expanding, Einstein's response had been that Lemaitre's physics was abominable.
Faced with Hubble's undeniable evidence, Einstein finally dropped the cosmological constant, lambda. He famously called its introduction his biggest blunder, but with lambda gone, Einstein's universe didn't fit an unmodified spherical geometry. His basic equations no longer agreed with the geometry of the universe. The math never predicted a spherical expanding universe, leaving behind a theoretical Frankenstein's monster. The combination of Einsteinian relativity and Hubble cosmology simply violates mathematics and geometry. The stitched-together Frankenstein's monster of Einstein-Hubble cosmology doesn't work, never did and never can. Thank you for watching True Physics.